Well, welcome everyone to the July Water Committee meeting, and beginning next month, we hope you'll have someone else to hear from other than me. But for this one, I just want to talk a little bit about the report that recently came out of the three universities in the state of Arizona. They together have a project that is called the Arizona Tri-University Recharge and Water Reliability Project, or ATUR. It's not a really catchy acronym. But the point of the project is to address what's important to us here in Arizona, which is how do we ensure that we have a reliable and sustainable water supply for the future. And there's a few things. There is the full report. They did put together a report between the three universities, and that full report is out. The link is on the webpage that I shared the link for this particular page, this project page. And so you can see the full report there. There are also a few things, like they have a newsletter that sort of summarizes it. I'm going to take a look at this newsletter in a minute just because it's good for a summary. They show sort of the project approach, the things they were looking at. They had some guiding questions they used when they were putting together the reports. So this is what guided the research at the Kyle Center at ASU, at CCASS at the University of Arizona, and I don't remember which particular part of NAU did it, but NAU also was working on this. So the three universities together did research on this. And here's a picture of their project team. You notice there is Sharon Megdal right there. So she's the person with the Water Resources Research Center at the University of Arizona. And she is one of the collaborators on this. Also, Neha Gupta just took over the project recently. The original director of the project stepped down. She was retiring from the university. And so Neha Gupta is stepping up. And she's been doing a lot of really incredible work on water and water reliability, and especially things like how much evapotranspiration occurs within Arizona. It's a much higher number than I ever thought. And so it's really great to see that she's going to be running this project going forward. Because I don't think this isn't the last of the reports coming out of it, but this was the first report that they put out from this Tri-University study group. And so let me move on to the next part. This is the newsletter. So this was announcing the release of the project. And so you can see that the report and the number of accompanying products. So they took a lot of their data tools and their mapping tools, they made those available as well, because they want people to be able to dive into this data on their own. And especially they're hoping that water managers will take advantage of the work that they've been doing. You can see here they were supposed to wrap up by June 30th of this year. So that was when they released this report. But they were provided an extension. So now they're going to continue through June of next year. So that's going to be ongoing work that they're going to continue working on. And I imagine there will be some new products and possibly a new report coming out of that. And so this is just a little bit about the report. These are the parts of it. Of course, there's an introduction that just says what the background for the project is, and also the things that make Arizona unique as far as our hydrogeology. That underlying ground and the soil types that affect how much water can infiltrate and where it can infiltrate. And then they also did a statewide water summary. So they looked at the state of groundwater across the state and put together some summaries for each of those areas. They looked at recharge across diverse landscapes. So, it's obviously much different in Flagstaff than it is in Tucson. Likewise, it's different in Tucson than it is in Phoenix. So, they looked at all these different areas as far as how much recharge potential there is and what different methods would work best. And then also for the resource managers, they came up with a decision support framework to share with them. Just, a process to go through as they're considering water issues and the things to look at as they go along. And then Section 5, of course, was they identified the data gaps in the future research that's required. And those are the things they'll be working on over the next year. There is an executive summary, which is probably a little easier for people who don't have a whole lot of time to read. And then there's also the report conclusions, which I'm going to go ahead and take a brief look at as well right now. So these are the conclusions of the report. Again, they do put a caveat right at the top that says, know that this can be misleading if it's not taken in the full context of the report. So, I'm sure that there are probably going to be some issues of people just jumping to the conclusion section and not understanding some of the background that goes into that. A few things, especially like enhanced recharge, there are a number of caveats to that. There are things that influence enhanced recharge, and they don't necessarily cover that here. But they do hit a lot of the key points and some of the things. Again, this is something that came out of Neha Gupta's studies, and it was amazing the first time that I heard her say this, that more than 95% of the precipitation that falls in the state is lost through evapotranspiration, which is not a bad thing necessarily, because, evapotranspiration is not just evaporation. We do lose a lot of water through evaporation, and that's one of the things they want to minimize. But the transpiration portion, of course, is what feeds the riparian environments, what provides those trees and grasses and the green things that we do want. And so, that's one of the things they're looking at is how do we make that balance between the water that we're not having available for people as well, at the same time that they're keeping areas green. So, it's a trade-off that they address in numerous places in the report, because it's one of those really important things that they're looking into. And it is a challenge for sure. In fact, some of the conclusions of the report, they look at things like, reducing forest cover in some places, which to me makes me cringe. But, there are some places where actually the forest has gotten too dense and it is drawing more water than it should be. And so, they're looking at ways that they can, a small change can make a big difference in how much water availability we have. There are also some things like, they have a guiding principles for enhancing recharge and habitat. I will take a real brief look at that as well. And then they, of course, say some obvious things like changes in precipitation intensity and frequency affect recharge rates. Looking at some of the hydrographs for the Tucson area, because that's the kind of thing I like to do for fun, I have noticed that that is a huge influence. We kind of underestimate it, but you can really see when we've had a rainy year in the hydrograph. So I know a lot of people like to take credit for, well, we've reduced our water consumption and we're not pumping water as much in the central Tucson area, those kind of things. But really a lot of it is, if we have a wet year, you can see the groundwater levels come up, and as soon as we have a dry year, they start dropping again, which is kind of what you'd expect. I mean, when you have more water available for recharge, the groundwater level comes up. So there's some interesting things there. They also have a capture and recharge opportunities matrix. I'll take a real brief look at that as well. Some of the things like dry wells and detention basins, which is something Pima County has been looking in. Pima County Regional Flood Control District has done some studies along with the University of Arizona in areas that are primed for enhanced recharge. And the form that would take in Arizona or in Tucson, because of our hydrogeology here, a lot of our soil within the Tucson basin is not really conducive to dry well infiltration. But there are certain places where they're already planning on putting large storm basins because it is a good infiltration location. And in order to get the water to go down faster, they're considering putting dry wells in those infiltration basins. So that's a good place for putting dry wells. I know we kind of had this policy with the water committee that we don't want to see dry wells everywhere, because in a lot of places in Tucson, they don't make sense. But when they're put in a large scale retention basin, they can help it drain faster and they can help get that water down into the aquifer. So it makes sense there. And that's pretty much what they're saying in this report as well. And they also even talk about increasing the length of time that flood flows are held in retention basins. Generally we like to see them drain quickly. Like if you're putting in a rain basin at home, it should drain within 24 hours because you don't want to have that mosquito breeding area. But for larger retention basins, it does make sense to let the water sit a little longer because it gives it more time to infiltrate. So that's another thing they're looking at, is that, if it may be necessary to change policy to allow some of the bigger retention basins to hold water longer than 24 hours. And some of the surface water flows start as groundwater outflow. That's not really so much in our area, but they do say, about a third of surface water flow in the state starts as groundwater outflow. So, it's originally underground in places like, for example, on the Navajo Nation and in the Hopi areas, they have water that is within mesas there, for example, that is water that's been held, and it seeps out through springs and becomes surface water. So those are some of the places where that happens. They are noticing, one of the points they make is that a lot of those aspects of water are not really well recognized by the public or by the legal system. Unfortunately, the way the law is in Arizona, there is no connection between groundwater and surface water. So it just doesn't recognize that often those are the same thing. And we have the reverse too. Here in Tucson, a lot of our surface water becomes groundwater. And so we still have those flows through our major rivers. They're just under the bed of the river at most of the length of the river. And so, again, we don't address that. We don't really treat that water as being the same as the surface water that gets certain protections from pollution and everything else and from overuse. And we don't provide those same protections to the groundwater that really is the surface water that has now moved underground. So a lot of things that are really interesting here. There's that decision support framework I was talking about that is for groundwater managers. Let me really briefly take a look at the portion that they had on, actually, I think that was the full report. Did I get the wrong part? I think I did. I pulled up the wrong link. This is the recharge opportunities matrix. Let me bring that one up. So this is a matrix that kind of talks about all the different things that you can do to enhance recharge. And so, there's everything that it's divided up by urban areas. So in urban areas, there are things like, design flood control facilities to maximize recharge, things like that, things that make sense. And also, as I mentioned, increasing ponding time to um, provide additional recharge, use dry wells in urban locations capable of recharge to reduce evaporative loss and increase infiltration. There are a lot of different things. Install permeable pavement, a lot of things that they looked at to try to increase infiltration within urban areas. And then, of course, in rural and developing areas, they talk about places to do things like capturing the water running off of roads, or integrating the forest management with water management, so that they're doing thinning or putting in roads in places where that enhances infiltration. So, there are a lot of things they looked at. Agricultural landscapes, they look at the ways to improve the water use for agriculture and also to improve that infiltration. One of the things that Neha Gupta's team noticed was that in certain agricultural areas in the state, the evapotranspiration rate is above 100%. And you might go, well, wait a minute, how can it be above 100%? But what it is it's not only is the rainfall evaporating or being lost to evapotranspiration, but also that irrigation water. So there's actually more water than the rainfall that falls on that land that is being evapotranspirated. So it's kind of a huge issue with agriculture. And that's one of the things they've been looking at, is how do we reduce some of that loss? And then in the sloped and mountainous areas, how can we help to encourage additional mountain front recharge, which is, for example, here in Tucson, that's where most of our aquifer recharge comes from, is the mountain front recharge. And so, how can we improve that? How can we accelerate that recharge, capture more of the snow melt coming off of the mountains so that we have that available to us? So that is kind of it. They also talked about grasslands. So, that would be like out on the Sonoyta Plain. How do we handle that sheet flow to be able to help the infiltration, floodplains, how do we manage water that's being lost a lot of times in the floodplain? How can we infiltrate some of that? Um, as you can see, it was a huge report with a lot of things that they looked at. So I would encourage everyone to take a look at this. It is a very interesting report with a lot of stuff to think about and to chew on. And there's a lot of it that does apply here in Tucson. And so, it's worthwhile for us to take a look at that. And that's all I've got on that.